Hi. These days you hear me talking mostly about migrations, but today I want to talk instead about domain-specific languages. Because yesterday we had a very interesting meeting with a client. Meeting was supposed to last 1 hour. In the end, I think it went on for 1 hour and 40. In this meeting, we were looking at the architecture of the DSL system that we built for them. And the way in which I introduced the subject was to say that if you want, you can divide the system in half. A part of the system has the job of producing the AST, and a part of the system has the job of consuming the AST. And so if you look at the things in this way, you can see how the AST is the central component of a similar solution. Now, how does it work in practice? In practice, in this case, we have a textual language, like most languages that you may be familiar with. And so we start with a parser, then through multiple stages, examine the code that the author writes, understand its structure, then it does some further processing, and in the end, it produces an AST, a representation of the information present in the code in a way that is convenient to work with. Convenient to work with means different things. Means that the information is structured in a certain way, but it also means that the tree is expressed using an API, a library, in this case Colasu, part of the Starlasu family of libraries, but is expressed through libraries that provide a series of facilities to work with the AST in a convenient and effective way. Then, working with the AST may mean different things in different contexts. In this case, the main usage was to interpret the AST to execute something. In this case, this is a DSL built for marketing purposes, so the authors can describe a certain promotion so that when certain conditions are met, certain events are triggered, like awarding a prize or a coupon or whatever. Now, in this case, the interpreter will navigate the AST and evaluating the expression, executing the statements, and producing some sort of visible result. This is one case, but there are cases, and in this project we've been discussing it, in which in addition or in alternative to an interpreter, you may want to have some form of compilation. Typically, this is intermediated by code generation, so you don't write an actual compiler. You generate some code for which you have already a compiler. You generate Java code that then you compile. But if you want, you can also generate the executable code or the bytecode yourself. So I've written some tutorials on this subject many years ago on navigating AST and producing some JVM bytecode that you can then ship it as if you have obtained it from compiling Java. But there are also other usages. So you could, for example, use the AST inside an editor, using information, for example, like the references to implement a go-to definition, or vice versa, find usages. Or you could show in the editor errors that are attached to the AST. So the AST is, certain people will call it the model, is the set of all the information organized as a tree with all the convenience and complication of organizing information in a tree. And so you build it, you prepare the work so that then you can consume it to do what you want, which is typically interpret or execute somehow or edit your code. Then we went in a little more details about the different stages of producing the AST. Parser, initial answer parsing, then parsing, mapping from parse tree to AST, then semantic enrichment, and so on and so forth. We look at the different steps of an interpreter, and maybe that could be an interesting topic for next time. But if you are interested in DSLs, you're curious, you have questions, you have comments, I'm always happy to hear them. Thank you and have a great day.